Hi, in this video, we will discuss how to perform tests concerning proportions. In our previous module, we used the standard normal table to create a confidence interval that will estimate the population proportion of a random variable. Similarly, when we do tests concerning proportions, we may also use that table. For instance, let's consider this example. A builder claims that heat pumps are installed in 70% of all homes being constructed today in the city of Davao. Would you agree with this claim if a random survey of new homes in this city show that 8 out of 15 had heat pumps installed? Use a 0.10 level of significance. The first step is to identify the given. The hypothetical population proportion in this scenario is 70% or 0.70. The sample proportion, denoted by P hat, is equal to 8 over 15, which is about 0.53. Our sample size, denoted by N, is equal to 15, and our alpha, which is equal to 0.10, giving us a confidence level of 90%. The next step is to formulate our hypothesis. Since we want to test the claim of the builder that heat pumps are installed 70% of all homes being constructed today in Davao City, our null hypothesis is the population proportion is equal to 0.70, whereas the alternative hypothesis is that the population proportion is not equal to 0.70. Next, we identify the critical value using the z-table. Since we set our alpha to 0.10 and we have a non-directional alternative hypothesis, we want to know the associated z-score of the middle 90% of our distribution. Illustrating this in our normal distribution curve, it looks like this. We have here the negative z, and we also have here the positive z. We know that from the center, going to this point is equal to 0.45. Also, from this point, from the center, going to this point, this is also equal to 0.45. Adding these two regions, we have 90%. Hence, this illustrates the middle 90 in the normal distribution curve. Therefore, we'll refer to the z-table and look for the values that is closest to 0.45. And these are 0.4505 and 0.04495. We now get the average of the associated z-scores of the two values, which are 1.65 and 1.64 respectively, giving us 1.645 as our critical value. Our critical region then is in this shaded area. The fourth step is to compute the calculated z using the formula z is equal to the sample proportion minus the hypothetical population proportion all over the square root of the hypothetical population proportion times the difference between 1 and the hypothetical proportion all over n. Substitute the values in the formula. We have 8 over 15 minus 0.70 all over square root of 0.70 times 1 minus 0.70 divided by 15. Using our calculator, we get the result, which is about negative 1.41. Locating the position of the calculated z in the distribution, it is somewhere here. Because this one is equal to negative 1.645. Therefore, in step 5, where we formulate our conclusion, We failed to reject our HO since the calculated Z is not in the critical region. This means that we do not have sufficient evidence to disprove the claim. For our next example, consider example 5.7. A commonly prescribed drug on the market for relieving nervous tension is believed to be only 60% effective. Experimental results with a new drug administered to a random sample of 100 adults who were suffering from nervous tension showed that 70 received relief. Is this sufficient evidence to conclude that the new drug is superior to the one commonly prescribed? Use a 0.05 level of significance. First step is to identify the given. The hypothetical population proportion is equal to 60% or 0.60. Our population proportion is equal to 70 over 100 or equal to 0.70. Our N is equal to 100 and our alpha is equal to 0.05, giving us a confidence level of 95%. Next, we formulate the hypothesis. Since we want to test if the new drug is superior to the one commonly prescribed, we want to test if the rate of effectiveness is greater than the current one, which is 60%. In other words, our HA is the population proportion is greater than 0.60. Whereas our null hypothesis is the population proportion is equal to 0.60. Step 3 is to identify the critical value and the critical region. Since we are dealing with a directional hypothesis, specifically the greater than, if we illustrate this in our normal distribution curve, our critical value is somewhere on the right of the distribution. And the critical region is somewhere here. Moreover, since our confidence level is 95%, what we want to know is the associated z-score of the 95th percentile. Furthermore, from the center to the left, the area is equal to 0.5, giving us the value of the remaining area, which is equal to 0.45. From our previous example, we know that the associated z-score is 1.645. Hence, the critical value is 1.645 and the critical region is somewhere here. Step 4 is to compute the calculated z using the formula z is equal to p hat minus p sub 0 over square root of p sub 0 times 1 minus p sub 0 all over n. Then, we substitute the values and we have 0.70 minus 0.60 over square root of 0.60 times 1 minus 0.60 all over 100. Using our calculator to solve for the value of z, we get the result of about 2.04. The position of the calculated z is somewhere here in the shaded region. Therefore, in step 5, we conclude that we need to reject our HO and accept HA, which means that the new drug is superior than the other. That's it for our video. Thank you very much for watching and have a good day.